Semester Review, Chapter 1. So we're going to look at the functions according to each of the parent function. So I mark it down. For number 1, we have the cubic because the x is being raised to third power. So compare that to the a times x minus h to the third power plus k to identify each of the parameter values. We have a equals -1. That means you have a reflection across the x-axis. H, so x minus 2, h is a positive 2. So I'm trying to emphasize that h is a positive 2. And then k is plus 1. So with h being positive, you're moving right 2 units. K being positive, you're moving up 1 unit. So I'm going to mark down. So my initial starting point is going to be moved from 0, 0 to 2, 1. Right 2, up 1. And then from there, because they're reflection, it's a cubic function. So I'm going to reflect the parent functions. So you'll see that the left-hand side up, right-hand side down. So we discussed the end behavior of the odd functions before. So left-hand side up, right-hand side down. Number 2, you see the bars across the x-axis. So that means it's going to be the distinctive absolute value functions. Again, compare that to the standard form of a times the absolute value of x minus h plus k. A is going to be 3. That means you have a vertical stretch by a factor of 3. It's going to go up faster, 3 times faster compared to the parent functions. X minus, so again, x subtracting a positive 1. So that means h is positive 1. K is -4. So we have right 1 down 4. Right 1 down 4. And don't forget, you are vertically stretched by a factor of 3. So from right 1 down 4, I go right 1 up 3, right 1 up 3 with a slope of right 1 up 3, because this is an absolute value function. So you should see the distinctive V shape. Number 3, sketch the piecewise functions by hand. So here I directly mark down, when we talk about piecewise functions, I directly mark down the dividing line. And obviously you can see that x less than -1 and x greater than -1, something changed there. So I mark down the dividing line, x equals -1. To the left hand side, 2x plus 1, x less or equal than -1, that's a linear equation. When x is greater than -1, it's a quadratic equation. And here I mark down, I did not try to use the slope-intercept form. I directly plug it in the points. So for the linear equation, I chose x to be -1, -2, and then I calculate the y value, corresponding y values. So with 2 points, I can graph a linear equation. Same thing for the quadratic equations. I plug it in -1, 0, 1, 2 to calculate, and as you can see, I mark it on my graph as well. So anything greater than -1, it's going to be a quadratic. Anything less than -1 or equal to 1, it's going to be a linear equation. Number 4, f of x equals square root of x minus 2. So when it comes to square root, don't forget the function has to be real number. So you have to limit your domain. So x would have to be greater or equal than 2. If x is less than 2, then whatever inside the square root is going to become imaginary. So you have to make sure, define your domain to be greater or equal than 2. With that, square root functions will have a range of greater than 1. How about the inverse? So here I wrote down the steps for you to write down the inverse. So first I name my equations y equals square root of x minus 2. And then don't forget, the first step is to switch the symbol from x to y, y to x, meaning that you are changing the input to output, output to input. Then the next step is solve for y. So you want to practice this pattern several times. That's the way we do for the inverse functions. You'll find the inverse is going to be x squared plus 2, which is a quadratic equation. How about the domain of the inverse? So as you can see on my note, I simply take the range from the original equations and then set it to the domain for the inverse functions, and I change the symbol from y to x. And then for the range, I do the same thing. I grab the information from domain for the original functions and then switch x to y again. Mark the graph, and then I put down the y equal x line to mark as the mirrors. So your original function should be mirrored across the y equal x line to the inverse function. So one is square root, the other is quadratic. Chapter 1, question number 5. Find the slope-intercept form of the line that passes through 2, -1 and is parallel to 4x minus 2, 3, 4x minus 2y equals 3. So first thing I need to find the slope for the line. The slope of the line I would have to rewrite into the slope-intercept form. So I subtract 4x to both sides, then divide by -2. I have y equals, so -4 divided by -2, that's positive 2. All I need the information from the first step is just the slope, which is 2, the slope only. Once I have the slope, I have the points. The points given to us is 2, -1. So the first number is always your x, the second number is always your y. So I use the point slope form, which is y minus y1 equals m times x minus x1. So I plug in the points. Y minus -1 equals 2 times x minus 2. Rewrite that into slope-intercept form. I have, or you can think of as solve for y. Solve for y. So the final answer is going to be y equals 2x minus 5. Number 6, find the slope-intercept form of the line that passes through -3, 2, and is perpendicular to y minus 6 equals 0. Y minus 6 equals 0, you can rewrite that as y equals 6. Y equals a constant means that you have a horizontal line. So the only line that's perpendicular to a horizontal line would be vertical line. And how do you express lines in vertical form? So x equals a number. X equals a number, and because it has to pass through -3, so x would have to be equal to -3. Number 7. So you are given f of x and g of x. So I would like to mention here the symbol notations. It looks like f plus g then times x. It is not. Remember we talked about this in chapter 1. F plus g of x equals f of x plus g of x. Personally, I like to use this second representation to note that it is a function adding another functions. F functions plus g functions, okay? The first one is given to you as in your textbook, but you still have to learn that. You have to remember that. But personally, like I said, I like to use the second notation, f of x plus g of x. So simply you take the f of x, which is x plus 3, g of x is x squared minus 9, combine them together, collect like terms, simplify if you can. So check on your answers. So for b of g, again, f minus g of x is the same as f of x minus g of x. Letter C, f times g. So f of x times g of x. F of x times g of x. You are multiplying the two functions together. You are not going to multiply another x. Letter D, dividing. So make sure you restrict the domain. So what cannot be your x values? Those numbers that will make your denominator equal to 0. So make sure you mark down what are the x values that's not okay. So x cannot be 3 nor -3. Letter E, g of f of x. So this is a composite function. So first you take the output from your f of x functions, which is x plus 3. Then put it into, insert into g functions. Whenever it comes to composite functions, make sure you start with the innermost function first. So g of x is defined as x squared minus 9. So our input is now x plus 3. So x plus 3 squared minus 9. Distribute, combine like terms. The final answer is x squared plus 6x. Number 8. Determine if the function is even, odd, or neither. So remember, what does even mean? Even means that if you plug it in -x, so f of -x is exactly the same as f of x itself. If you replace the x with negative of x and evaluate the functions and you get the exact same thing as the original f of x, then it's an even function. If you plug it in f of -x, you get the result as multiplying the whole functions by -1, then it's going to be an odd functions. If neither of them works, then all you can say is the function is neither an odd function nor an even function, but it can still be a function. So please remember, in order for functions to be even, it has to pass the f of negative of x equals f of x. For functions to be an odd function, it has to pass f of negative of x equals -1 times f of x. So check on your answers. First one, I have odd. Letter B, I have neither. Letter C, it's an even. Letter D, it's neither. Number 9. So it looks like a quadratic equation. It looks like a parabola. It's going to be a quadratic equation. What kind of transformation? So the easiest way to identify this would be looking for the vertex. So the vertex went from 0, 0 to right 3 up 5, right 3 up 5, and then it's being reflected. Do you see that the quadratic equation is being reflected down? You have a set face parabola. So how do I write the equations? So reflection, I take care of it by multiplying the whole function by -1, and then right 3, so x minus 3 up 5. I add 5 to the functions. Chapter 2. Solve by the given method. So number 1, you are asked to do the factorings. So if you like to use the factoring fish method, make sure you put it on factor fish. So put the quadratic, which is 3x squared at the front, constant the second. What numbers make up 3x squared? So I have 1x times 3x. -5, I can try -1 times 5 or -5 times 1. Once you find a combination, what do I mean by the combinations? So as you multiply it together, 1 times -5, you get -5x. 3x times +1, that's 3x. -5x plus 3x, I have -2x. So you find the combinations that works for your linear term. Once you have this, don't forget to write your factors diagonally. So I have x plus 1 times 3x minus 5. Solve for the x, set each of the factors equal to 0. Means that x plus 1 equals 0, 3x minus 5 equals 0. So I have x equal to -1, x equal to 5/3. Number 2, completing the square. So x squared minus 4x. First step, I add 10 to both sides. Second step, since the leading coefficient 1 times x squared, 1 times x squared, I'm taking the linear term coefficient. So linear term has a coefficient of -4. Take -4 divided by 2, which is -2, square that. That's +4. So I add 4 to both sides. That makes my left-hand side a complete square, x minus 2 squared. To the right-hand side, 10 plus 4, that's 14. Take the square root on both sides. As I do that, I put on positive and negative to both sides. So I have x minus 2 equals positive or negative square root of 14. The last step is add 2. So my final answer is x equals 2 plus or minus square root of 14. Number 3, quadratic formulas. Quadratic formulas, nothing much can be done here. Nothing much needs to be done. All you have to do is identify the parameter values for a, b, c. So a is the coefficient for quadratics. B is the coefficient for linear, and then C is your constant. So we have A equals 3, B equals -4, and then C equals -5. Plug it into the quadratic formulas. So the final answer is 2 plus or minus square root of 19 over 3. Number 4, any method. Even though it says any method, because it's more than 3 terms, so I should try factor by grouping. Factor by grouping. So what do I mean by factor by groupings? I'm going to group number 1, number 2, first and the second term together, third and the fourth term together. That's factor by grouping. Whenever it's more than 3 terms, I definitely try this. So this way I can factor the whole thing into x plus 3 times x squared minus 2. set each of them equal to 0. Means that x plus 3 equals 0, x squared minus 2 equals 0. So I have x equal to negative 3, and then x equal to positive or negative square root of 2. Number 5, factor completely given x plus 2 is a factor. So whenever you are given a factor, remember if a number is a factor of the other one, then the remainder is going to be 0. So that's the key point here. Remainder is 0. So since the given factor is in linear term, I'll just linear equations, I'll just use the synthetic divisions. Synthetic divisions I have to rewrite into x minus, which is x minus negative 2. So negative 2 will be my divisor here. And for the dividend, so dividend x squared x cubed plus 6x squared plus 11x plus 6. So no terms are missing. So I'll simply take the number 1, 6, 11, 6, and then use the synthetic divisions. Then I get x squared plus 4x plus 3 as the quotient. From there, I can use the factoring fish to further factor it, which is x plus 3 times x plus 1. So everything being factored down to x plus 3, x plus 1, and then x plus 2. Number 6, find the polynomial functions given the following. Degree of 3. So the degree of 3, then you should have 3 zeros. But you're only given 0, 1, and 2i. So what's the missing one? Again, we have degree of 3, you should expect 3 zeros. And take a further look, you have the 2i. So according to the complex root theorem, when you have 2i as one of your roots, then you should expect negative 2i is going to be your root as well. So let's plug that in. X minus 1 times x minus 2i times x minus negative 2i. Given the zeros, all you have to do to find the original function is by setting it into x minus, because as you plug it in these zero values, it will make the whole functions equal 0. That's the whole idea of why it's being called zeros. So the functions for number 6 is going to be x minus 1 times x squared plus 4. Number 7, simplify. So simplify, we practiced this recently. All I'm going to say is keep real number real, keep imaginary number imaginary. So first one, number 7, distribute. I have 12 minus 3i minus 4i plus 6. So combine the real number with real. 12 plus 6, I have 18. Negative 3i minus 4i, that's negative 7i. Number 8, how do you simplify a fraction with a complex number form? So all you have to do, remember, is multiply your top and bottom with the complex conjugate. So 3 minus I, you keep the real parts exactly the same, 3, and then you change the sign for your imaginary part. So change that into 3 plus I. You multiply that top and bottom. And don't forget, our I squared equals negative 1. So make sure you rewrite that. So the final answer for number 8 is 1 minus I over 2. Number 9, write in standard form, then graph. So this one, I'm using the completing square format, x squared minus 4x plus 4 minus 3. So I rewrite into x minus 2 squared minus 3. So that means my vertex is being moved right 2 down 3. From there, I do my normal count. Right 1 up 1, right 2 up 4, right 3 up 9, left 1 up 1, left 2 up 4, left 3 up 9. Number 10, find the information, then graph. X cubed plus 4x squared minus x minus 4. So again, this is more than 3 terms, so I can try the factor by groupings. So I can factor the whole thing to x plus 4 times x plus 1 times x minus 1. That means I have the x-intercept located at negative 4, 1, and negative 1. And then I'm going to plug it in some points that's outside of my x-intercept. between my x-intercept and then a points beyond. So I chose to calculate -5, -3, -2, 0, and 2. And then you can calculate these y values, plug it in to have a more accurate graph. The more points you have on your graph, the more accurate your graph will look like. Number 11, rational expressions. So f of x equals x minus 3 over x minus 2. How do I find the x-intercept? So set your numerator equal to 0, which is x minus 3 equals 0. I have x equal to 3. So mark that point on your graph. How about the y-intercept? Y-intercept is by setting your x equals 0. So plug it in 0 for top and bottom. 0 minus 3 over 0 minus 2. So that becomes 3 over 2. Are there any holes? So holes means that you should have the same common factor top and bottom. So since they are both linear equations, there's no common factor top and bottom. Vertical asymptote. Vertical asymptote is by setting my denominators. So my denominator is x minus 2, so set it equal to 0. X minus equal to 2, x equal to 2. So x equal to 2 is a vertical line. So mark that down. Horizontal asymptote, because both of them are linear equations. So you take the leading coefficient of each, then that should be the horizontal asymptote. So my top numerator has 1 times x, the bottom has 1 times x, so 1 over 1. The horizontal asymptote is y equals 1. The next is, how do I find the values for the table? We can plug it in any points you want. So since we already have the x-intercept, the y-intercept, so I just plug it in some points in between to fill out the graph. Number 12, find the information from the graph. So you're given a function, given the graph, you're rewriting the functions. So the x-intercept, I read it as 2, 0. Y-intercept is 0, 2. Holes, there's none. Vertical asymptote. So vertical asymptote is located at x equal to -1. Horizontal asymptote is located at y equals to -1. So those information should help us write the equations. So again, x-intercept can be used for my numerators. So if x equals to 2, that'll make the numerator equal to 2, then I will write it as x minus 2. For the vertical asymptote, I have the information for my denominators, x plus 1. And then the horizontal asymptote, -1, so I have to multiply that by -1. And then the last step is by checking with your y-intercept. If you plug it in x equals 0, 2 minus 0 over 0 plus 1 is indeed equal to y-intercept value y equals to 2. Chapter 3, we were talking about exponential functions and logarithm functions. So first thing, you have to make sure that you have the same base. Logarithm converting back into exponentials. Logarithms to exponentials. Exponentials to logarithms. So I listed all the steps for you to do the problems. Take a look, check your answers. Ask me if you have any particular questions on this portion. Question number 4 and 5. These are calculating the interest and the money you earn by putting the money in the bank. So let me read the formula for you. A of t, so A of t means that the final value you have as you deposit money into the bank. A of 0, so this is the initial amount, initial money you deposit into the bank. A of 0. So A of 0, the whole thing represents the initial values. Times 1 plus r over n. R is your interest rate given to you in annual interest. N means that how many times you are being compounded. If it's once a year, then your N is going to be 1. If it's 4 times a year, means quarterly, then N is going to be 4. If it's monthly, then your N is going to be 12. So depending on how many times your interest is being compounded, so make sure you change that number for your N accordingly. And then at the same time, you have to raise your exponent. So see that the exponent has the N in it as well. So make sure you multiply your N to the exponent. So these are practicing of calculating the interest, the principal times the interest get you the final amount you have. A of t, final amount of money you get from the bank. A of 0 is the initial amount. R is the interest rate. N is how many times it's being compounded. Chapter 4, we just did this review, so I'm going to let you check on the answers. So you can pause these videos to write down the informations, or you can get the handwritten copy from me later on. And then, as I have been always reminding you, make sure you practice your table, the 6 trig ratios. You need to be able to do this as you finish this course. So the 6 trig ratio table is very, very important. Make sure you practice it. The final page of this review packet. Again, we just did this, so I'm going to let you check on the answers. Play with the calculators. Make sure you are able to find the degree and radian informations for the trig functions.